My dear friends, welcome to Rajashekhar classes on Applied Data Science with Python. This is lecture number 193. In this lecture, I will continue my discussion on logistic regression. Let's take one example. This example is taken from Statistics for Business and Economics 11th edition by David R. Anderson. This is an excellent book to understand statistics concepts. First, we will try to understand example. Let us consider an application of logistic regression involving a direct mail promotion being used by Siemens stores. Siemens owns and operates a national chain of women's apparel stores. Here, 5,000 copies of an expensive 4-color sales catalog have been printed, and each catalog includes a coupon that provides a $50 discount on purchase of $200 or more. The catalogs are expensive and Siemens would like to send them to only those customers who have the highest probability of using the coupon. Here you must understand variables. What are the variables in the problem? Actually, what you have to do, now we have to identify for what kind of customers we have to target so that they will use the coupon. Before that, what are the variables in this problem? If you observe carefully, here I have two variables. One is annual spending. I have a variable, this one annual spending, and another one is customer has a Siemens credit card. We will try to understand. Siemens conducted a pilot study using a random sample of 50 Siemens credit card customers. There are 50 Siemens credit card customers and 50 other customers who do not have Siemens credit card. Siemens sent the catalog to each of the 100 customers selected, isn't it? At the end of the test period, Siemens noted whether the customers used the coupon or not. If you observe carefully, as I told you, there are two independent variables. First one is annual spending. Just see, this is one variable, annual spending. That is one independent variable. Second one is whether the person have credit card or not. Customer with credit card or without credit card. I can say these two variables are independent variables. Just see this one. By using this data set, we are going to construct logistic regression equation model so that they can target to whom this catalog can be sent, so that they will use the coupon so that the sales will increase. This is the data set. I have shown only 10 customers, but there are 100 data set. 50 customers are not having the credit card, remaining 50 are having the credit card. Spending is one of the independent variable. I already discussed this one. Just see, this is one independent variable. Let me say x1, isn't it? Spending is one of the independent variable. Having or not having credit card is also another independent variable, x2. What is the meaning? One means, what is the meaning of card? One means having the credit card, and 0 means not having the credit card. Here the coupon also, here just see coupon column. Here the coupon also, 0 means they are not using the coupon. What is the meaning of this? not using the coupon, isn't it? In similar manner, what is 1? 1 means using the coupon. 1 means they have used the coupon. So the coupon is the variable. That is going to be the dependent variable. You must understand here. This coupon is dependent variable. Whereas this spending and card are, these two are, I can say, independent variables. Which are our independent variables? Spending and card are independent variables, whereas coupon is dependent variable. So the coupon is the variable. This is going to be the dependent variable. X1 is spending is one of the independent variable. X2 is card. Card is another independent variable. You see that X2 is categorical variable. Actually, just say X2 1 0 means there are only two categories. In this it is given that whether the person is having the credit card or not having the credit card. I can say that is a categorical variable, isn't it? Just observe here, just we are showing only 10 customers data. In reality, we will take 100 customers data, isn't it? Now we will go for what is the explanation of the variable. The amount of each customer spent last year at Siemens is shown in thousands of dollars, and the credit card information has been coded as 1 if the customer has Siemens credit card and 0 if not, isn't it? It's not new thing. Two variables. One is how much spent in the last year. What are the two variables? I already discussed these two variables. What is first variable? How much spent in the last year. My first variable is spent in the last year. Spent in the last year, isn't it? That's first one. Whether the person have the credit card or not. That another variable is having the credit card, or not having the credit card. There are two possibilities. I already discussed in previous slide. If the person have the credit card, we are coding it as 1, isn't it? If the person having the credit card 1, otherwise it's 0. If the in the coupon column, which is dependent variable, yes, this is coupon is dependent variable. 0, a 1 recorded if the sampled customer used the coupon. 1 means what? What is 1? If the sampled customer used the coupon, and 0 if not, isn't it? These are the explanation of variables. What are the variables here? As I told you, here y is coupon, that is dependent variable, and I have another let me show, otherwise in previous slide, let me go back and show this one. Just see this one, just a minute. Yes, here you must understand, this is x1, this is x2, this is y. Y is dependent variable. X1 comma x2 are independent variables. Just you can say spending is independent variable, card is independent variable, coupon is dependent variable. Means this coupon depends on spending and having card or not having card, isn't it? It's straightforward. This is simple explanation of variable. First we will try to understand what is the logistic regression equation. Just see, if the two values of the dependent variable y are coded as 0 or 1. What is dependent variable here? Coupon. The value of E of phi, that is expected value of phi, in equation given below provides probability that y equal to 1 given a particular set of values for the independent variable x1, x2, so on, xp. What is probability y equal to 1 means? What is y? Y is coupon, isn't it? What is means y equal to probability of y equal to 1 for given x1, x2, so on, xp means, what does it mean? For given independent variables, x1, x2, so on, xp are independent variables. y equal to 1 means, y means what? Coupon. 1 means using coupon. Probability of using coupon for given independent variables x1, x2, so on, xp, isn't it? This is logistic regression equation. What is our logistic regression equation? E power beta naught plus beta 1x plus beta 2 x2 plus so on, beta p x power p by this one. What is the maximum value of this one? For example, this may be the maximum, it may be infinity, isn't it? If it is infinity, what happens? This value will be e power infinity by 1 plus e power infinity. E power infinity means infinity, and again infinity plus 1. This is indeterminate form. In that case, what you have to do? Just what you have to do? Just see, just remove this one. If it is an indeterminate form, what I have to do? Just see e power infinity by, just take e power infinity common, 1 plus e power minus infinity. This as e power minus infinity means what? 0. 1 by 1 plus 0, I can say 1. Its a maximum value is 1, isn't it? What is the minimum value? This may be minus infinity. E power minus infinity by 1 plus e power minus infinity. In that case, if I take e power minus infinity common, what happens? 1 plus, I can say e power infinity. That's 1 by 1 plus e power infinity. E power infinity is infinity, 1 by infinity means 0. My intention is just, even I can show it, but just understand e of phi maximum value. What is the maximum value of e of phi? Maximum value of e of phi is 1, and the minimum value of e of phi is 0. It is just similar to probability. What is the maximum probability? 1, and minimum probability is 0. This is something like sigmoid function, isn't it? Anyway, we will spend a lot of time on this particular equation in future classes. Just see here what it says. The two values of the dependent variable y are coded as 0 or 1. The value of e of phi in the equation provides the probability that y equal to 1 given particular set of values for the independent variables x1, x2, so on, xp. So logistic regression equation, this equation I can say this one is logistic regression equation. Your expected value of e of y equal to this one. We are going to predict y. It is going to be 0 or 1, isn't it? Now, you may ask one simple question: why not we use simple linear regression equation here? Because simple linear regression equation cannot be used for this problem, because there are two possibilities. We have assumed that when you plot this data set, one assumption is that the error term in simple linear regression should follow normal distribution. Just try to recall, in the case of simple linear regression, your error term must follow normal distribution. Just try to recall. Error term must follow normal distribution, isn't it? Just it is a case of linear regression, isn't it? Y variable you have only here. In this case, what is in this case? What is y? Y is coupon. How many possible values does it have? Either it has 1 or 0. Only two possible values. So I can say it is following binomial distribution. You must understand this one. Your dependent variable is following binomial distribution. If your dependent variable follows binomial distribution, then I can say you must apply logistic regression, and the error term of logistic regression will follow binomial distribution. So you cannot use your simple linear regression if the dependent variable y value is categorical variable. It is taking two categories, 0 and 1. Therefore, as dependent variable is categorical variable, I must make use logistic regression, isn't it? What is this expected value? E of phi. E of phi equal to, what is the meaning of this one? Just see, because of the interpretation of E of phi as a probability, the logistic regression equation you can write like this: E of phi equal to P of y equal to 1. What is y? Y means what? Coupon, isn't it? What is this y? Y is coupon. Y equal to 1 means using coupon for given independent variables x1, x2, so on, xp. So we are going to find out expected value of y. This is the example. Just see, if you observe, why we cannot use, just I will show one simple output. Anyway, I will show in your Jupyter notebook also. Just this is screenshot of your Jupyter notebook. Just see, plt dot scatter. I already discussed about scatter plot in data visualization. df dot spending on x-axis. We are taking spending on x-axis and coupon on y-axis, isn't it? Coupon on y-axis. Your marker is plus, that's why it's showing plus markers, isn't it? Color is red. Anyway, that's a matter of visualization. It's simple and straightforward. I already discussed data visualization. What is the scatter plot in data visualization classes? So you can understand, you cannot apply linear regression. Why? Because there is no straight line. There is no line. Therefore, you cannot apply linear regression. So what will happen here? No way. We cannot construct line, because here x variable is spending and spending is continuous. Here just see, this is x is spending, this is x variable spending, isn't it? Spending. What about y variable? Y variable is coupon, isn't it? Let me repeat here, x variable is spending. Spending is a continuous variable, and y variable is a person is used coupon or not. So what's happening, whenever their income is low, or they just say whether income is low, they are using coupon, and even income is high, they are using also more. When the incomes are more, in that case also they are using coupon. So you cannot construct a linear regression for this particular data set. When you fit linear regression, this kind of I can say this kind of data set, there is no meaning for that, isn't it? Why? Because I cannot fit a straight line for this particular data set. So one way to fit the line for this is I can say like this. So one way to fit the line for this kind of data is a S-shaped curve. Just see, this is something like S-shaped curve, isn't it? It's anyway. I will show you next slide. What is this S-shaped curve? Just see, it is something like this, isn't it? I can say the expected value is nothing but the probability. Here you must understand, this one is probability. This one is probability. Probability minimum value is 0. Maximum value is 1. Note that the graph is S-shaped curve. It is just like S-shaped curve, isn't it? It is sigmoid function, isn't it? This is S-shaped curve, isn't it? The value of E of y ranges from 0 to 1, isn't it? Minimum value is 0, maximum value is 1. The value of E of y gradually approaching 1 as the value of x becomes larger. Just see, as x is increasing, as x value is increasing, gradually it reaching 1. Just see, this is 1, isn't it? It's 1. It's gradually it's reaching 1. As x increases, this function reaches 1, approaching 1, isn't it? I can say like this. Let me repeat. The value of E of y gradually approaching 1 as the value of x becomes larger, and the value of E of y approaching 0 as the value of x becomes smaller. As I told you, the value of E of y representing probability, isn't it? Now I can say, just if you observe this particular graph carefully, just see here, this you see that the E of y value is getting maximum value whenever the value of x is increasing. If this value of x is between 3 and 4, just see this one, between 3 and 4, it's increasing almost, it's 1, isn't it? There is a higher chances that the expected value of y will be 1 if as x increases. When x is increasing, I can say when x is above 3, I can say expected value is almost 1. When it is below 2, just see, if it is below 2, what's happening? There is a higher chances that the expected value becomes 0, isn't it? There are two possibilities, and the rate of change also very high between 1 and 2. Just see, in between 1 and 2, that rate of change is very high. Height is increasing rapidly, isn't it? Rate of change is very high in between 1 and 2, but between 2 and 3, the rate of change, just see this, between 2 and 3, the rate of change is low, but between 3 and 4, the rate of change is more. Just observe this graph, isn't it? If you are carefully observe, you can understand these observations. This is S-shaped curve for a logistic equation. So what we are understanding here, when x equal 3, whenever the value, I can say, whenever the value of x is more than 3, I can say like this, whenever the value of x is more than 3, more change, I can say more change, the value of expected value of y will be 1, isn't it? When it goes below 1 or below 2, there is a more chance that expected value of y will be 0. When you go to right hand side, just if you keep on moving right hand side, there is a more chances that expected value of y becomes 1. Now we will go to estimation of logistic regression, but before that, just spend this time how it is increasing in between 2 and 3. Just you are getting straight line, isn't it? If it is above 3, you are getting 1. This value almost it's equal to 1. If it is below 2, it's approaching 0. This is a shape. This is the logistic regression equation. I can say this is strictly following that equation. Which one? Your E of y equal to e power beta naught plus beta 1x plus beta 2. Beta 1 x1 plus beta 2 x2 plus so on beta p xp, this beta p xp by 1 plus e power beta naught plus beta 1 x1 plus beta 2 x2 so on. This is the equation whose maximum value is 1 and the minimum value is 0, isn't it? Yes, this is the shape of this particular curve, and you can understand what's happen if x increases, what's happening if x is decreasing, what's happening, you can analyze, isn't it? In simple linear and multiple regression, the least square method is used to compute b0, b0, b1, so on, bp as the estimate of the model parameters beta naught. This is actually beta naught, beta 1, beta 1, so on, beta p. What it says, in simple linear and multiple regression, the least square method is used to compute b0, b1, bp to estimate model parameters. What are the model parameters? It's related to population, beta naught, beta 1, beta 2, so on, beta p, isn't it? These are sample parameters, b0, b1, b so on, bp, isn't it? What is the model? With the help of sample parameter, we can estimate, with the help of b0, b1, bp, we can estimate beta naught, beta 1, beta 2, so on, beta p. But the previous equation, what is that equation? E of y equal to, just recall that equation, E of y equal to, anyway we know that e power beta naught plus beta 1x, so on, that equation, isn't it? The logistic regression is non-linear. So the non-linear form of logistic regression makes a method of computing estimates more complex. So what we are going to do, so whenever there is a nonlinear form of equation, instead of using ordinary least square method, you have to make use MLE. What is this MLE? Maximum likelihood estimation. In the case of logistic, maximum likelihood estimation method, I can say, isn't it? Instead of writing, let me say like this: MLE to predict the population parameters. So all software packages that follow the concept of maximum likelihood estimation. Again, I am repeating, in the case of linear regression and multiple regression, we are using OLS, ordinary least square method, to estimate population parameters with the help of sample parameters, whereas in the case of logistic regression, where we will use maximum likelihood estimation to estimate the population parameters with the help of sample parameters. What is this MLE? I will discuss in future classes. Just time being, understand this maximum likelihood estimation is useful to estimate our population parameters, beta naught, beta 1, so on, beta p, with the help of sample parameters B0, B1, BP. That's what it says. The nonlinear form of logistic regression equation makes the method of computing estimates more complex. So that as it is more complex, which one I have to use? I must use maximum likelihood estimation method. I will continue my discussion in next class on logistic regression. Just go through this lecture. Certainly you can understand. If you have any difficulty, just keep a comment. Thank you very much.